So I want to talk about Advent of Code Day 4. A friend of mine who's learning Haskell approached me once, and when I saw this, I thought to myself, this is solvable using Comonads. So basically what I'm doing now is just create a video that I would have liked to have seen 5 to 7 years ago. Yeah, I will only do the first part. I don't know what the second part is, but that really doesn't matter, I guess. So you get a grid made up of strings, and you are supposed to find all occurrences of a certain substring in all dimensions. So forward, backward, diagonally, and all. We will do so using any other language. You would just use a matrix, and you can also use a matrix in Haskell. What I will do now is present a different concept to view this problem. And basically, what I'm thinking of is that this is a multi-dimensional string, so you could also extend the dimensions to 3, 4, 5, whatever. And the code which solves this problem would still work after adapting the structure, which always stays the same. But we will get to that. So Comonad is what we will use at the end. So I will start at the beginning. Also set up the project just in case there are people who are new to Haskell. There are certain things you should be already comfortable with, otherwise you won't get as much out of it. But I don't know, this didn't stop me in the past to just watch videos about Haskell. So maybe there are a few others who feel the same. Okay, everything works. Yeah, hello world, hello Haskell. Okay, let's just copy that string here and get this for future reference. Yeah, good. So that's our string. So since we won't be using a standard matrix, we have to come up with a different approach. And basically, we'll first start with the one-dimensional case, which just goes to the left or the right. And for that, we will use a zipper, which we will define like this. So a zipper is basically a structure which allows us to focus an element and also keep track of the elements before and after it. So since it's so easy to view it like this, we will just go ahead with the convention to, if we focus this element here, everything to the left is in front of it, everything to the right is behind it. So what we then can do is define left, and going to the left means we have a zipper. If there is, oh wait, so left, focus, right, let's start out like this. Since Haskell has pattern matching, all we can do now is account for the condition that there is nothing to the left. Instead of throwing an error or encapsulating it in the type system, we will just keep the zip list the way it is. So if we are at the beginning of the zipper, we will just return the zipper itself, right? Otherwise, there will be elements to our left, which then means you can just create a zipper, move one to the left, focus the element that was previously in front of it, and prepend the previously focused element to the right side. So then also do the same for right. This time we invert the logic. So if we have nothing to the right, we will just stay to the right. And this is just everything to our left. This time we have that far right. L, F, L, A is now focused, and to the right is all the rest. Okay, yeah, I'll also go ahead and add some ticks here because later down we will create a grid, and I don't want, and I want to be able to reference grid operations without the tick. Let's give zip also a show instance. Left, focus, right. You can just concatenate all three substructures. So what we now want to do is this. We want to show F. Then, yeah, we also want to show all elements to the left. And as is apparent here, a implicit convention we have is that everything to the left of the focused element is also in reverse order. So when we show it, we have to reverse the list first and then show the result to the left. And concat map show right, we have to do the same here. Concat map show. So this, we want to print our zip list. Zip. And we'll just take the first. So now we also have to create a way to create a zipper. Okay. We will keep the zipper focusing on strings. So intuitively, what you can do is go from string to char, which then means you would have always a char focused, and afterwards to the left and the right always a string. But what we will want to do is focus strings, which makes stuff down the line easier. Okay, so first, when we create our string, our zip, we will always start at the beginning. We will then use the head of S, so the first element of the string, and we will just have the convention that the string we pass here is never empty. And we get the tail of S. This should fail now because head of a string returns char. Yep. And we want a string, so we can use singleton, which is from the data list module. Data list module up here, right? And this makes a string out of a single char. And here we want a list of strings. And tail just gives us a string. So what we have to do is we have to map singleton onto all elements and tail. Okay. We go ahead now and run this. We have the first element focused. Let's go on to the right. We have the next element focused, and left also works as expected. We first go to the right and then go to the left. We come back to the beginning. Yeah, this is the tree. Okay. So far, so good. Let's keep going, because now we want to create a grid, right? we would like to have a grid, which basically is a zipper of zippers. And the outer layer of the zipper should allow us to focus on which row we are interested in. And the inner layer of zippers allows us to focus which column we are interested in. Grid. Grid is a zipper of zipper A. And this is basically everything. So let's see, what do we do if we want to go left in a grid? If we go left in a grid, first we have to access our zipper. So ungrid G, right? Into ungrid G. And now it gets interesting. So going to the left in a grid means we focus or we shift our columns that we focus at one to the left. To make that obvious right now, this means if we have this case here, oops, so we have this part, let's say here, and we have this grid focused. I will just make this super obvious. So this means the outer zipper has this one focused and the reverse list of zippers here to the left of it, and this to the right. If we want to go to the left, we want to move the focus of all zippers one to the left, which means we want to fmap left onto the result. So what then happens is what we then do is just apply, go to the left once to all zippers inside our grid. And the result of this then just can be brought back to a grid. Oops. We can just move this here. We can move this and also do that stuff. Now the thing is, there's no functor instance for zip. We can solve this issue without any problem. Functor of zip A. So we have to define fmap. Returns gets f. It's f left focus. Okay, focus element. We will just use it. Just call it A now. This returns a zip list, and we just fmap f onto the left side. We apply f to the focused element, and we apply f to all elements to the right. Yeah. So now we have that stuff. We can do the same for right now. And we go to the right. So up and down is a little different, because if we want to go up now, we want to be here, right? Oops. Oh, we have to apply left to the outer zipper if we want to go up, and right to the outer zipper if we want to go down. Grid A, up. Okay, this time we have to ungrid as well this time, and then we have to apply grid again. And this, since ungrid returns a zipper of zippers, and we want to apply left to the outer zipper, we just can do this. Now we can do right to go down. All right. So, okay, let's do something which allows us to create a grid. Make grid. What we will do is you will receive a list of strings and give us a grid of strings. Yeah, this, make it like this. Let's first create a zipper for each string inside our list. And then create our grid. Then create the outer zipper by focusing the first element for the inner zippers and the rest to the right. Oops. Okay. So this allows us to create a grid, and now now I want to see that this is correct, which means create another show instance. Show grid. Okay, yeah, this is a little bit more involved. I want to show it basically like this. So let's first get access to the outer grid. Let's first get access to the outer grid. We can destructure here. For the top, we can, so for everything above the currently focused element, we can just map show onto everything to the left. For everything at the bottom, we can map show everything to the right. And for the focused element, we want to again declare or hint at the focus element using square brackets, and this way we can just combine them all, right? Which should just be able to do this, right? Can I do this? No, I don't know why I thought this is possible. Unnice. Okay. Let's then create an extending grid. We call this grid. We'll use this. Oh, okay, I'll make a grid. Let's see, we should have the first element focused. Color run, which is true, right? So the first row is focused, and then the first element of the first or of each row. Okay, we can now go ahead. We can go 2 to the right, and we can go 1 down. Let's go 2 to the right and 1 down, and this is exactly what happens. Right, we can go 1 more down. Okay, so this works as we want it to work. This is nice. Good. Now for the fun part, because this is just the basic structure that we need to solve the rest of the task.